Hi there and welcome to this video on some exam questions based on correlation and regression, and it is focused on the Edexcel S1 A-level module but is applicable to most other exam boards. And as always, if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Okay, so let's crack on with some exam questions here. So this is from the June 2010 paper, and it says that Gary compared the total attendance X at home matches and the total number of goals Y scored at home during a season for each of 12 football teams playing in a league. He correctly calculated the following summary statistics below, and we're asked to calculate the PMCC for these data. So in the formula book, we're told that the PMCC is worked out by doing S x y over the square root of sxx times by s y y. So all we're going to do is plug these values into our calculator to get the correct answer. So for 2 marks, we're going to start by putting in the values in the correct place. So 8, 8, 2, 5 all over square root of 1022500 times by 130.9, and that's the PMCC, or sometimes called R. Right, out with the calculator. So 8825 all over square root 1022500 times by 130.9. We get a value to 3 significant figures of 0.763. So to 3 sig figs, 0.763. So that's our 2 marks. 1 mark for this and 1 mark for our answer. Interpret the value of this correlation coefficient. Essentially, we can see that it's a positive correlation. It's kind of close to 1. So I would say that teams with higher attendance, or with higher attendance, score more goals. Okay, and that's where you get your 1 mark there. Do not just say that it's a strong positive correlation. You must interpret what that correlation means. Okay, next part. Helen was given the same data to analyse. In view of the large numbers involved, she decided to divide the attendance figures by 100. She then calculated the PMCC between x over 100 and y. We're asked to write down the value that Helen should have obtained. It's just for 1 mark, and you should know that coding has no effect on the PMCC. So in this case, R will be the exact same. It will be 0.763. Okay, so the volume of a sample of gas is kept constant. The gas is heated and the pressure P is measured at 10 different temperatures T. The results are summarized below. So we're given our summary statistics here, and we're asked to calculate SPP and SPT. So SPP is going to equal the sum of P squared minus the sum of P to be squared divided by n. So sum of P squared is 38125 minus the sum of P, which is 445 over n, which is 10, and that's squared. Okay, so let's plug this into a calculator. Three, 8, 1, 2, 5 minus 445 squared all over 10. And that gives me 18322.5. 18322.5. And I'll prefer not to round at this point because in part B I'm going to be asked to calculate the PMCC, so I don't want to lose any accuracy. Okay, now I need to calculate SPT. So SPT will equal sum of PT minus sum of P times the sum of T over N. So let's substitute these values in. Sum of PT is 26830 minus sum of P times sum of T, 445 times by sum of T, 240 over 10. Again, whip out the calculator again and just plug in the values. 26830 minus 445 times by 240 all over 10. That equals 16150. And notice what I have in the calculator display here is exactly what I've written out here. 16150. Okay, so now we're given STT. Calculate the PMCC. And the PMCC are equals SPT divided by square root of SPP times STT. SPT, we've worked out 16150 divided by the square root of SPP, which is 18322.5, 18322.5 times by STT, 21760, 21760. So out with the calculator, 16150 over square root of 18322.5 times 21760. That gives me 0.809 to three significant figures. 0.809 to 3 sig fig. Give an interpretation of your answer to part B. So as the temperature increases, the pressure increases. Okay, and just note again that I didn't just say that it was strong positive correlation, which is what the number suggests. I'm actually interpreting what it means. Okay, let's move on. So the weight W grams and the length L in millimeters of 10 randomly selected newborn turtles are given in a table below. Find the equation of the regression line of W on L in the form W equals A plus BL. Now I'm actually going to save myself a load of time by using my calculator for this. We could just go and work out, we can go and work out B by doing SWL divided by SLL. That will give me B, and then I can work out A as well using the formulas that are given in the formula booklet. But seeing as I have a calculator that will do all the hard work for me, that's what we're going to do. So I'm in statistics mode and I need to choose option 2, which is linear regression. So I'm going to put in my two values here. The x values, by the way, just to make you aware, the x values correspond with L because generally it's in the form y equals A plus bx. So the x values are going to be L and the y values will be W. So let's plug these values in. 49, 52, 53, 54.5, and I'm going to continue on entering these values now. So I'm just going to pause the video just to save a wee bit of time. Okay, so I've got all my data entered here. You might actually notice in the right hand side it says frequency of 1. That's just the same as if I had the frequency turned off. So now I'm going to use the calculator to work out the value of A and the value of B. So if I hit Shift, Stat, and option 5 for regression, I can work out A, which is option 1. So A is going to be equal to minus 60.445. I'm going to round this to 3 significant figures. So it's going to be minus 60.4. So A equals minus 60.4. And then I can get B as well by using the calculator. So Shift, Stat, option for regression. Option 2 is going to give me B. And B equals 1.797. So let's go to 3 significant figures, which will be 1.80. B equals 1.80. Just to clarify there, if I'm going to 3 significant figures, I want to round to this figure here. So looking at the 7, I have to round up, which adds 1 onto 9, which subsequently adds 1 onto the 7. So now I have A and B. I should now be able to work out the regression equation. So we get W equals minus 60.4 plus 1.80 times L. The next part, B, says use your regression line to estimate the weight of a newborn turtle of length 60 millimeters. So this is just plugging a value into the regression equation we've worked out. So I want to know what the answer to W will be if L equals 60. So that gives us, we'll get W equals minus 60.4 plus 1.8 times 60, and bringing up our calculator again, we get minus 60.4 plus 1.8 times 60 gives me 47.6. So 47.6 grams. Okay, so part C now says comment on the reliability of your estimate giving a reason for your answer. So I got to look at L. L is 60, and as we can see, the data I have, the lowest value is 49, I think. 49 is the lowest value. The highest value is 54.5. 60 is outside of that range, so that means I would say it's an unreliable estimate. Unreliable, as it was extrapolated. So because it was extrapolated, in other words, it's outside the range of the data we have, it's unreliable. Okay, so now it says that a teacher is monitoring the progress of students using a computer-based revision course. The improvement in performance Y marks is recorded for each student along with the time, X hours, that the student spent using the revision course. The results for a random sample of 10 students are recorded below. And we're asked to calculate SXX and SXY. Okay, so like before, we have our summary statistics here. SXX equals the sum of x squared minus the sum of x all squared divided by n. So plugging the values in, sum of x squared is 57 Let's just erase that. This is 55, 57.22 minus 21.4 squared all over. Let's just double check again. I think it's 10. It is 10 students. So out with the calculator. Let's go back to regular mode. 57.22 minus 21.4 squared over 10. And we get 11.424. I'm going to leave it like that, 11.424. And I also need to calculate SXY. And SXY equals sum of XY minus sum of X times sum of Y all over N. So let's plug these values in. 313.7. 13.7 minus sum of X, which is 21.4, multiplied by the sum of Y, which is 96, all divided by N, which is 10. Right, so out with the calculator. Here we go. 313.7 minus 21.4 over 10. That's multiplied by, and again, just pay careful attention to my calculator display here, times 96. What I've got on my calculator display is exactly what I've written down. That equals 108.26. 108.26. And I cannot stress enough the importance of actually writing this calculation down before you start to plug it into your calculator, because if you make a mistake with the calculator, you can still pick up marks for writing this bit down. Okay, and next part, it says find the equation of the least squares regression line of y on x in the form y equals a plus bx. Now this is another great opportunity to use the calculator to do all the tricky work. We could work out R, we could work out A and B using the formulas, but I have the raw data here, so I'm going to let my calculator do all the hard work. So we're going to go to stat mode. It's two variable statistics, and I'm going to enter in the values here. So the x value is 1, 3.5, etc. The y values, the corresponding y values, which are important, 5, 30, etc. So I'm just going to pause the video now and plug in these values. You can have a go as well. So minus 5, just finishing off here now. 7, 15, minus 10, and finally 20. So in goes my data, and then I just hit shift, stat. I want option 5 for regression. I need the value of A, which gets calculated to be minus 10.6797, etc. So let's just round it to three significant figures. A is minus 10.7. So A equals minus 10.7. And B we can pull out of the calculator as well. So shift, stat, option 5 for regression. B equals 9.476 to three significant figures, going to be 9.48. So B is 9.48. So then plugging it into this, we get y equals A, which is minus 10.7 plus 9.48 times x. And that's our 4 marks. Be very, very careful when you're using the calculator to get these, that you just double check that you're putting in the right values, because if it does go wrong, you're going to lose a lot of marks. So do be wary of that. Okay, next part of the question, we're just going to move on to the next slide just so we can see what's going on. Give an interpretation of the gradient of your regression line. So let's have a look. The gradient is 9.48. X was the number of hours. and that's a positive number. So as that number increase, or as the number of hours increases, the value of y, or the number of marks, should increase as well, because it's got a positive gradient. So what I can say is that effectively for every hour they study, it produces another 9.5 marks. Okay, so if x was 1, I'm going to add on roughly 9.5 to the number of marks. If I have 2 hours, it's going to be 2 times 9.5. So effectively, for every hour, was it studied? Let's see. Time spent on the revision course, for every hour on the revision course produced around 9.5 extra marks. Okay, it says that Rosemary spends 3.3 hours using the revision course. Predict her improvement in marks. Okay, so this is a classic example where I'm going to have to sub this in. The equation was y equals minus 10.7 plus 9.48x. So let's just write that down again. Y equals minus 10.7 plus 9.48x. What is the improvement in marks? Well, I'm only really looking at this area here. So what's the improvement in marks? Is going to be 9.48 multiplied by 3.3. So let's take out the calculator. 9.48 multiplied by 3.3 gives me 31.284 equals 31.284. Of course, I need to factor in the minus 10.7 as well. So I'm going to do 31.284 and subtract away 10.7. So 31.284 minus 10.7 gives us 20.584. Let's go to three significant figures. 20.6 marks. 20.6 marks. So the improvement in marks is 20.6. Okay, it says that Lee spends 8 hours using the revision course, claiming that this should give him an improvement in performance of over 60 marks. Comment on Lee's claim. So what we need to do is check and see what happens if we plug in 8 for x. Now the one thing I would be wary of is the fact that 8 hours is well outside the range of data collected. So because it's only for 1 mark, I'm not even going to do the calculation. I'm going to say that Lee's claim is unreliable as it's outside the range of data collected. Outside the range of data collected. Okay, let's move on. So, crickets make a noise. The pitch V in kilohertz of the noise made by a cricket was recorded at 15 different temperatures T. These data are summarized below. Find STT, SVV, STV. So, STT is going to equal the sum of T squared, which is 10922.81, minus the sum of T all squared, which is 401.3, to be squared over n, which is 15. So I'm going to plug these values into the calculator. 10922.81 minus 401.3 squared over 15, which gives me 186.6973333. Now, I'm not actually going to round this at this point because I'm just looking at part 2. It asked me to find the PMCC. I want to keep things as accurately as possible, so let's take the exact answer, 186.6973333. Right, 186.6973333. Excellent. Right, let's do the same now for SVV. Okay, and just a reminder, the reason why I didn't do this, I do not want to lose accuracy later on in the question. So let's keep things as tight as possible here. Right, we need the sum of V squared, 42.3356, minus sum of V squared, 25.08 squared, 08 squared over 15. Remember, the squaring is only happening to this number here, not the 15. Out with the calculator. 42.3356 minus 25.08 squared all over 15. That gives me 0.40184. 0.40184. 40184. And then finally STV. Let's do it over here. STV is going to equal sum of TV 677.971 minus sum of T times sum of V, 401.3. 1.3 times by sum of V, 25.08. 25.08 all divided by N, which is 15. Okay, so here we go. 677.971 minus 401.3. I'll put the 15 in now. Go back up and multiplied by 25.08. And we get 6.9974. So equals 6.9974. Okay, so that's part A completed. 4 marks going there. Find the PMCC coefficient or PMCC between T and V. And that's going to be calculated as STV over square root of STT times SVV. And this is why I didn't round earlier on. I want to keep my answer as accurate as possible. STV is 0.6 or 6.9974. So we get 6.9974. By the way, this is R. 6.9974 divided by square root of STT, which is 186.6973333 multiplied by 0.40184. 0.40184. And it may seem cumbersome to put these digits in like so. However, it maintains our accuracy. 6.9974 over square root 186.6973333 times by 0.40184, and we get 0.807869281. I'm happy enough now to round this to 3 significant figures, so let's go with 0.809. or sorry, 0.808 should I say, 0.808. 808, and you'd be hard pressed to find a more accurate answer than that, other than putting this in here. Okay, state with a reason which variable is the explanatory variable. So let's look at this closely. The explanatory variable is generally the independent variable, and I think the independent variable in this case is the temperature, because the temperature will be fixed and the pitch depends on the temperature. So T is the explanatory variable. Having trouble spelling today. Explanatory. As it is independent and V depends on T. And in general, the explanatory variable is whichever variable is in place of x, because we're used to y equals a plus bx. Whichever one is in place of x is your explanatory variable. Give a reason to support fitting a regression model of the form v equals a plus bt to these data. And quite simply, what we'd say here is we seem to have a strong positive correlation. Strong positive correlation. And that's found as R is close to 1. Find the value of A and the value of B. Give your answers to 3 significant figures. Okay, so we don't actually have the raw data here, so we're going to have to use some formula. And in the formula booklet, to get B is usually calculated by doing SXY over SXX. SXY in this case is the same as STV, and SXX is STT. It's important we choose the correct values. STV is 0.40184. It's not 0.40184, I beg your pardon. It's 6.9974. So let's just modify that. 6.9974. STT is 186.6973333. And again, just as well that we kept these as full answers because we want to maintain accuracy. So here we go. It's going to be 6.9974 over 186.6973333, and we get 0.0375 to 3 significant figures. So I'm going to round this to 3 significant figures. Right, 0.0375. 0.0375. So the 3 sig fig, that's what we get there. And if we remember, to get A is calculated, and it's in the formula booklet. A is equal to y bar minus B times x bar. That's the general formula. In this case, A is going to be calculated by doing, now we've got to be very careful here, y bar is going to be calculated from V bar. Okay, Y bar and V bar are equivalent, minus B times T bar. Remember, T was the independent variable. So that's going to be calculated by doing, let's see, V bar is calculated by doing the sum of V divided by 15. That gives me the mean of V. So I'm going to do 25.08 over 15. That's my V bar. Minus B, which is 0.0375 times by T bar, and T bar is calculated by doing the sum of T divided by 15, 401.3 over 15. 401.3 over 15. And let's take out the calculator to do this. Oh, this is fantastic. I still have my exact value for B from earlier on, so I'm actually going to use that. I'm going to multiply my answer by this, 401.3 over 15. Close off the brackets. That gives me this value here. I'm going to multiply it by minus 1 to make it negative. Multiply by minus 1 to make it negative. Now we have this, and I need to add on this part here. So I'm going to add on 25.08 over 15. And let's just delete that bit. Come outside. There we go. And we get 0.669287, etc. Let's go to three significant figures, 0.669. Okay, so we have the value of A, we have the value of B. The equation of the line, or the regression equation, is given in the form y equals A plus B times X. So it's going to be y is V, so V equals A 0.669 plus B times X. B is 0.0375 times X, which is T in this case. And that's the equation of the regression line. Okay, and then finally we're asked to use this model to predict the pitch of the noise at 19 degrees Celsius. The pitch, remember, is V, so we're just substituting if V is equal, or we're wondering what V is equal to if the temperature T equals 19. So we get V equals 0.669 plus 0.0375 multiplied by 19. And again, we'll take out the calculator to do this. Okay, here we go. 0.669 beg your pardon, plus 0.0375 multiplied by 19 gives me 1.3815. 1.3815. Okay, let's move on. Next question. It says a personal manager wants to find out if a test carried out during an employee's interview and a skills assessment at the end of basic training is a guide to performance after working for the company for 1 year. The table below shows the results of the interview test to 10 employees and their performance after 1 year. We're given some data. We're also given some summary statistics, and we're asked to show our working clearly, calculate the product moment correlation coefficient between the interview test and the performance after 1 year. Now I'm going to save myself a little bit of time and use the calculator to do all the hard work for me. So let's go to statistics mode again and enter the values here. So 65, 71. I'm just going to pause the video now and continue on entering these values. You can do so too. 61, 65, 79, 69. Okay, so all our data is entered there, and if I hit Shift 1, option 5 for regression, if I choose option number 3, that will give me the value of the PMCC, which is going to be 0.155 to 3 significant figures, 0.155, and the question is completed. Now, in order for, if you were to do it the traditional way, you're going to need to work out the sum of x, you're going to need to work out the sum of y, you're going to need to work out sxx, you're going to need to work out syy, you're going to need to work out sxy, and then use all of that to work out r. But I can let my calculator do all the hard work and pick up my 5 marks. One thing to be careful of, ensure that you enter the data correctly. Okay, now it says that the PMCC between the skills assessment and performance after 1 year is minus 0.15623 significant figures. Use your answer to part A to comment on whether or not the interview test and the skills assessment are a guide to performance after 1 year. Give clear reasons for your answer. And what I would say is that both of them are actually fairly weak correlations. We can see that this is close to 0 and that's also close to 0. So neither are actually give a clear indicator of whether they're a guide to performance. So both are weak correlations. So they do, or they are unlikely. They are unlikely to give a guide to performance. Okay, let's move on. Right, the chief executive of Rex Cars wants to investigate the relationship between the number of new car sales and the amount of money spent on advertising. She collects data from company records on the number of new car sales C and the cost of advertising each year P. The data are shown below in the table. Alright, we're asked to use the coding x equals p minus 100 and y equals 1 over 10 times c minus 400, and then draw a scatter diagram to represent this data, and then finally to explain why x is the explanatory variable. Okay, so we're going to need a table of sorts here. So I'm just going to pause the video and build up a table over here on the right. Okay, so table is complete and we're going to work out x, and that's equal to p minus 100 for each one, and y is going to equal 1 over 10 times c minus 4000. So we're going to start to fill in the values here. P minus 100, we're going to get 20, 26, 32, 34, etc. I'll fill that in a second. And we've got to do C, C minus 400, or 4,000 that should be. Let's just alter that. 4,000, 0, 0. So C minus 4,000. And then divided by 10. So I'm going to get 240 divided by 10. I get 24. And then I'm going to get 38, etc. So again, I'm going to pause the video here and just fill out this table. Okay, and you should have something like that. So that's the coding done, and next I need to draw a scatter diagram to represent the data and then explain why x is the explanatory variable. Um, so we'll get to that in a second. Let's just do the scatter diagram. So I'm going to need a scale on the x-axis that goes up as far as 60, and I'm going to need a scale on the y-axis that goes up as far as 80. So again, I'm just going to pause the video here and build up my scatter diagram, well, the axes, and then we'll start to plot the points. So that's our scatter diagram, the scales done, and this is the variable x, which is sales. I don't think it's sales actually. Let me just double check. I'm going to go back here. Um, X is the cost of advertising, and the Y will be the number of new car sales. So cost of advertising, cost of ads against the number of new car sales. And then it's fairly straightforward. We just plot the points. So again, I'm going to pause the video and just plot these points. Okay, so your scatter diagram should look something like that. Notice that we've got clearly labeled axes, and our points are correctly plotted. Be as accurate and meticulous as you can when you're plotting your points. You don't want to give the examiner any reason to deduct a mark. And then I think the last part was to explain why x is the explanatory variable. And basically, x is the independent variable, and the number of car sales depends on the cost of advertisements. So, um, as the um, the as the expenditure on ads goes up, of advertising, I'm just going to write ads goes up, it influences the number of new car sales. Okay, so x is your independent variable, and y is your dependent variable. So as we increase the cost, or the amount we spend on the ads, that will increase the number of new car sales, or influence it at least. Okay, next part of the question is find the equation of the least square regressions line of y on x. And again, we're given some summary statistics here. So this is a 7-mark question. There's obviously quite a bit going on. Right, the first thing we're going to need is the value of A and the value of B. In order to get B, I need to get S, X, Y, and I need S, X, X. So a little bit of work to be done here. Let's go for S, X, X first. S, X, X equals the sum of x squared, which is 17538, minus the sum of x all squared, 402, to be squared over n, which I think was 10. Let me just double check. Does it say in the question? No, let's just count 1, 2, 3, 4, 6, 7, 8, 9, 10. Okay, so over 10. And let's bring out the calculator for this. 17538 minus, oh, let me just put it back in statistics mode so you can clearly see what's going on. Not statistics, regular mode. 17538 minus 402 squared over 10, and that gives me 1377.6. 1377.6. That's SXX. I need SXY now, and SXY equals the sum of XY, 22611, minus the sum of X times the sum of Y, 402 times by 517 all over n, which is 10. So again, out with the calculator. 22611 minus 402, 10 there, and up we go, times 517 all over 10. And we get 1827.6. 1827.6. So now let's plug these values into the calculator. 1827.6 all over SXX, which is 1377.6. So 1827.6, divide my answer by 1377.6, gives me 1.326655052. Let's go to 3 sig fig. 1.33. So equals 1.33. In fact, I want to keep this as accurate as possible because I'm going to use this to calculate A. So 1.333. I'll leave that in the calculator for now because A is calculated by doing y bar minus B times x bar. Y bar in this case is going to be 157 over 10. 517 over 10, should I say, minus B 1.33, or what I have in my calculator I'm going to use, times by x bar, which is 402 over 10. 402 over 10. Okay, now I can let the calculator do the hard work here. So that's the value of B, the exact value of B. I'm going to multiply it by 402 over 10, which gives me this. Okay, now I'm going to multiply it by minus 1 to take care of that. Multiply by minus 1 gives me that, and then add on this part because this is positive. So add on 517 over 10. And we get A, which is to 3 significant figures, is going to be minus 1.63. So we get minus 1.63. So we have the value of A, we have the value of B, and y equals A plus B times x. So minus 1.63 plus 1.33 times x. So that's the equation of the least square regression line. That's of y on x. We now need to get it for c on, oh no, we got y on x, that's it, that's our 7 marks there. The next part is to get c on p. Now I just want to, I'm going to pause the video very quickly and use the calculator to check and see if I did this correctly. So what I'm going to do is, let's go back here, I'm going to plug these values into my calculator and see if we get the same values for A and B. So I'm going shift setup, I beg your pardon, we're not doing setup, we want mode, statistics mode, regression, and I'm going to put in the values for x and y. So 20 will go on for the value of x, corresponding y 24. Okay, so I'll just pause the video now. I'm going to fill this in. Okay, so I've entered all the data here. Let's just go back to the slide that we were dealing with, and we can check and see if we got the correct answers. A should be minus 1.63. So after we enter our data, I hit shift stat option 5 for regression. Let's check the value of A. Did we get it correct? Oh, to 3 significant figures, minus 1.63, so that's perfect. Let's check the value of B, which is option 2 here. B is 1.3266, so to 3 significant figures is also 1.33. So we could actually save ourselves a little bit of time without having to work all of this out by just entering the data like we've done earlier. Alright, the next part says deduce the equation of the least squared regression line of C on P in the form C equals A plus BP. Now we have to remember that Y was equal to 1 over 10 times C minus 4,000. Let's write that down. Y was equal to 1 over 10 times C minus 4,000. And X was equal to P minus 100. P minus 100. Right, so wherever I have an X, I'm going to substitute in P minus 100. Wherever I have a Y, I'm going to put 1 over 10 times C minus 4,000. So it's a bit of changing the subject. So Y, we're going to get 1 over 10 times C minus 4,000 must equal minus 1.63 plus 1.33 times X, which is now P minus 100. Okay, so we get, let's multiply everything by 10 just to get rid of this. So I get C minus 4,000 equals minus 16.3 plus 13.3 times P minus 100. Leave the left hand side alone. So we get minus 16.3 plus 13.3 times P, and when I multiply 13.3 by minus 100, I get minus 1330. Okay, almost there. I'm going to add 4,000 to both sides, so I get C equals minus 16.3 plus 13.3p. When I add 4,000 onto this, and let me just, I want to use the calculator here, make sure I make no mistakes. 4,000 minus 1330, I get 2670 plus 2670, and then finally just tidying up this bit, minus 16.3 and 2670, we get C equals 2670 minus 16.3 gives me 2653.7. So we get 2653.7 plus 13.3p. Okay, interpret the value of A. Right, so we're choosing A from, I'm guessing from this equation here. And what I would say is this would be the numbers sold if nothing was spent on advertising. So if P was 0, I would expect to sell 2,653 cars. So it's the numbers sold if nothing spent on advertising. That's probably for 1 mark. And then I think it's also important that we recognize that if P was equal to 0, which is well outside the range, it's meaningless because it would be extrapolating then. If P was equal to 0, then it is meaningless. Alright, last part, part E. Predict the number of extra new car sales for an increase of 2,000 in advertising budget. Comment on the validity of your answer. So Let's just try and make a little bit of space. I hope we have enough space in here to fit this in. So 2,000 is going to be spent, an increase in 2,000 on the advertising budget. Remember, this is in thousands already, so 2,000 is going to be the equivalent of 2. So I want to know what happens when P is equal to 2. So what's going to happen? We'd end up with 13.3 multiplied by 2, because it says 2,000. So 13.3 times 2 is going to be 26.6 cars. So 26.6 cars sold. And if we notice, 2 is well outside of the range of data collected. So it's extrapolated. Therefore not reliable. Okay. Next question. A company owns 2 petrol stations, P and Q, along a main road. Total daily sales in the same week for P and for Q are summarized in the table below. So we have some data here, and the data is coded, and we're given some summary statistics. We're asked to calculate SXY and SXX and SYY. Okay, so this is a little bit like the last question. I'm going to pause the video again. I'm going to, well, actually, we don't even need to calculate. We don't need to uncode or code all this data because it's already done for us. We're given the summary statistics, so it should be fairly straightforward. Right, I need SXY. So let's start with SXY. SXY equals sum of XY, which is 204.95, minus sum of X times sum of Y, so 48.1 times the sum of Y, 52.8, all divided by N, which in this case is 7. Okay, out with the calculator. Let's go back to regular mode. Right, 204.95 minus 48.1 times 52.8 all over 7. That gives me minus 157.86 14286. Let's take the exact answer here, just in case we need it later on in the question. Minus 157.8614. Alright, here we go. Minus 157.8614, 286. SXX. XX is going to equal sum of X squared, which is 486.44, minus the sum of X, all squared, 48.1 to be squared, all over 7. Let's plug this into the calculator. We get 486.44 minus 48.1 squared over 7. 155,924,2857. 155,924,2857. 924,2857. And then finally we need to get SYY. SYY equals sum of Y squared, 613.22, minus sum of Y all squared, 52.8 squared, over 7. Okay, out with the calculator again. 613.22 minus 52.8 squared over 7. 226.9342857. 226.9342857. 9342857. Okay, so that's SXY, SXX, and SYY. Let's see what the rest of the question asks. Calculate to 3 sig fig the value of the PMCC. And then it asks to write down the value of the PMCC for the P and Q, and then give an interpretation of the value. So, alright, I need the PMCC, R, which is given as SXY over square root of SXX times by SYY. Right, let's go back a little bit. I'm gonna drag these over. Let's take all of this, copy it, and actually I should group it first. Technology failing me there. Let's try that again. I'm going to group and copy and paste that in. Obviously you can't do this in the exam, but you should be able to see everything clearly. Alright, so what am I going to write down for the examiner? I'm going to write down that I'm doing minus 157.8614 divided by square root of 155.9242.857 multiplied by 226.9342857. So we're going to have as accurate an answer as possible. Alright, minus 157.8614.286 divided by the square root of 155.9242857 times 226.9342857. In it goes, and out comes minus point. Let's go to 3 sig fig here. Minus 0.839. 839. Alright, so that's the PMCC between X and Y. Write down the value of the PMCC between P and Q, and you should know that coding has no effect on the PMCC, so that is also minus 0.839. And then finally give an interpretation of this value. So let's just go back. The company owns petrol stations P and Q, and we're comparing the daily sales in the same week for P and Q. So what we say is if P if petrol station P has good sales, then petrol station Q will have good sales. So in other words, in fact, it's a negative correlation. So if P does well in sales, then Q won't do well in sales. The higher the sales in P, the lower the sales in Q. So if P has a good day, chances are Q will have a bad day, and vice versa. The lower the sales in Q. Okay, I just did a quick check of the mark scheme there. I must have made a little mistake when I was typing this into the calculator. I don't want to redo the whole question again. I'm very, very close to the correct answer, but just in case you're wondering, there is the actual mark scheme. SYY was actually 214.95714, and that obviously leads to a slightly different answer for R, which is minus 0.862. But I suppose it's worth noting that um, I've written out pretty much all the calculations I've done, so I would have picked up most of the marks in the exam. So do be wary of that, and make sure that you show the examiner what calculation you are doing. Anyway, let's move on. Okay, an office has the heating switched on at 7 a.m. each morning on a particular day. The temperature at the office T degrees was recorded m minutes after 7 a.m. The results are shown in the table below. Calculate the exact values of SMT and SMM. Alright, so we're going to have to work out, there's a few things we need to calculate here. We need the sum of M. I'm going to need the sum of M squared. I'm going to need the sum of T. I'm going to need the sum of T squared. And I'm going to need the sum of MT. So I'm going to let my calculator do all the hard work here by putting it in statistics mode, two variable statistics, and let's enter our values here. So let's see. M is going to take the place of X and T takes the place of Y. So 0, 10, and I'm just going to pause the video while I enter these values. Okay, so all the values have been entered there. Now I'm going to use the calculator and the statistics mode to work out various different things. So if I hit sum, I can pull out the sum of X, which in this case is the sum of M. So option 2, 150. Sum of M squared, shift stat, option 3, sum of M squared is going to be sum of X squared, so option 1, 5500, and following that along we can enter them in. So again, I'll just pause the video while I fill these values in. Just filling in the last one here, sum of MT, which is going to be sum of XY, 2147. Alright, so SMT, and again I'm going to use the calculator here just to demonstrate how I can work out this problem fairly quickly. And remember, sum of MT is going to be the sum of, SMT is going to be sum of MT minus sum of M times the sum of T over N, which in this case is 1, 2, 3, 4, 5, 6. Alright, now we can use a calculator to do this. Shift, stat, sum. So I'm doing the sum of MT, which is the same as the sum of XY in this case, minus, and we're going to, let's just delete that. Shift, stat, sum again. So we need the sum of M, which is the same as the sum of X in this case, multiplied by the sum of T, which is the same as the sum of Y, or option 4 in this case. And I'm just going to put some brackets around this, because when we're in statistics mode it won't let me do a fraction properly. That's divided by 6, and we get 357. And I also need to find SMM, which is going to be found by doing the sum of M squared minus the sum of M all squared over 6. So again, we can use a calculator to do this. Shift, stat, sum. So I need sum of M squared, which is the same as sum of X squared, minus the sum of M to be squared. I'm actually going to put a bracket up here. sum of m, which is the same as the sum of x here, sum of x squared, close that bracket, divided by 6. Gives me 1750. 1750. Okay, next part, I'm asked to calculate the equation of the regression line of t on m in the form t equals a plus bm. Because I've entered all the values into the calculator, half the battle is done. So I'm just going to pull out the value of a by choosing regression option 1 for a, which is 6.8333 recurring. Let's write it to 3 sig fig as 6.83. The value of b, again shift 1, go into regression, choose option 2, which is b, gives me 0.204. So b equals 0.204. So that means t equals 6.83 plus 0.204 times m. And that saves me having to calculate b and a in the traditional manner. Next part, use the equation to estimate the value of t at 7.35 am. Okay, so it's very important that we interpret the question correctly here. Let's just read it again. It says an office heating switched on at 7 a.m. each morning, and they record the temperature m minutes after 7 a.m. So after 10 minutes, it's 8.9. After 20 minutes, it's 11.8. So that effectively is at 7:10 a.m. This is 7:20 a.m., etc., etc. So to work out the value of t at 7:35, I'm going to let m equal 35 minutes. So we get t equals 6.83 plus 0.204 times 35. Let's bash it into the calculator. 6.83 plus 0.204 times 35. 13.97. Degrees. Okay, state, giving a reason, whether or not you would use the regression equation in B to estimate the temperature at 9 a.m. that day. Well, obviously not, because that's way outside the range. The temperature, we only recorded temperatures between 7 and 750. So I would say no here, as 9 a.m. is outside the range of data collected. In other words, it was extrapolated. It would be extrapolation. And 7:15 a.m. 1 month later. Let's just have a look at this. 1 month later. I suppose that would be, it would be okay to use this. Yes. Here. As it would be interpolation, because it's inside the range of data, and the temperature is unlikely to change dramatically in a month. So that should be okay for our 4 marks. And I would say no here at 7:15 a.m. 1 month later, as no evidence. We've no evidence that the model will apply 1 month later. For example, the building in the office building could have some renovations done within that month. So there's absolutely no evidence to suggest that we can use this model a month later. Okay, students in Mr. Braun's exercise class have to do press-ups and sit-ups. The number of press-ups X and the number of sit-ups Y done by a random sample of 8 students are summarized below. Evaluate SXX, SYY, SXY. Okay, so SXX, I'm going to save myself the hassle of writing it all out. Let's just whip out the calculator. We should be getting used to this formula at this stage. It is given in the table book. Hopefully you're starting to remember it off by heart. So the sum of x squared, 10, 1, 6, 4, minus the sum of x all squared, 272 squared, over 8, because we've got 8 students. That gives me 916. In the exam, do bear in mind, write out this calculation that you're going to do first. Don't just plug in the answer. SYY is going to be the sum of y squared. 1313464. So what I'm putting into the calculator here, you should be writing down, minus sum of y all squared, 320 all squared, over 8. So that's what you should have written down, and you get 664. And then SXY will equal sum of xy, 11222, minus sum of x, 272, times by the sum of y, 320, all over n, which is 8, and we get 342. Calculate the 3 decimal places, the PMCC between x and y, and r equals SXY over square root of SXX times SYY. That's what you're going to put into the calculator. Again, let's save some time here and try and keep things moving along. SXY 342 all over square root of SXX 916 times by SYY 664. That's what you should have written down, and we get to 3 decimal places, 0.439. 439. Give an interpretation of your coefficient. Okay, so it's not really a strong positive correlation. And what are we measuring here? Press-ups and sit-ups. The number of press-ups is X, the number of sit-ups is Y. So what it would suggest is that, yeah, the more sit-ups, the more press-ups a student does, the more sit-ups a student does. Because as the number of sit-ups increase, so does the number of, as the number of press-ups increase, so does the number of sit-ups. So as the number of press-ups a student does, so does the number of sit-ups. So if you do more press-ups, you're likely to do more sit-ups. Okay, calculate the mean and standard deviation of the number of press-ups done by these students. Press-ups, remember, was X. Right, so the mean, or X bar, is going to equal sum of X over N, which in this case is 272 over 8. So let's pull out the calculator. 272 over 8 gives us 34. 34. And the standard deviation, let's just write down the variance first. Remember, the variance is the mean of the squares, sum of x squared over n minus the square of the mean, sum of x over n all squared. Right, so we're going to do sum of x squared, which is 10164 over n, which is 8, minus the mean of the square, so 272, sorry, the square of the mean, 272 over 8 to be squared will give me that, 229 over 2, 229 over 2, and to get the standard deviation we take the square root of our answer, take the square root of my answer, and we get 10.7 to 3 sig figs. 10.7 to 3 significant figures. Alright, an experiment carried out by a student yielded pairs of XY observations such that the mean of x is 36, mean of y is 28.6, and we're given SXX and SXY. Calculate the equation of the regression line of y and x in the form y equals a plus bx and give your values of a and b to 2 decimal places. Okay, let's start by working out b. So b equals, and this is in the formula book as well, it's SXY over SXX. So 3477.6 over 4402, 3477.6 over 4402 gives us, let's go, it says to 2 decimal places, 0.79. And remember, a is equal to y bar minus b times x bar. So y bar minus b times x bar. In this case, y bar is given as 28.6 minus b, which I'm going to use the exact value which I have in my calculator, 0.79 times x bar, which is 36 times 36. So that's my exact value for b, so I'm going to use that. Take my answer, multiply it by 36. So that's effectively these two numbers multiplied together. I'm going to multiply by minus 1 to make it negative. Multiply by minus 1 to make it negative. And then this is a positive number, so I'm going to add it on. Plus 28.6. And we get to 2 decimal places, 0.16. A equals 0.16. Right, find the value of y when x equals 45. So in order to work that out, I just need to write down the equation of the regression line. So y equals a plus b times x. Okay, I want the value of y when x equals 45. So y equals 0.16 plus 0.79 times by 45. Whip out the calculator. 0.16 plus 0.79 times by 45, we get 35.71. Okay, let's move on. The long distance lorry driver, a long distance lorry driver recorded the distance traveled m miles and the amount of fuel used f litres each day. Summarised below are the data from the driver's records for a random sample of 8 days. The Data are coded such that x equals n minus 250 and y equals f minus 100. Find the equation of the regression line of y on x in the form y equals ax plus b. Alright, so another occasion where we need to work out a and b. So let's start with b. In order to get b, I need sxy and sxx. Right, so I need to get sxy first. So let's get sxy, which is equal to is the sum of xy minus the sum of x times the sum of y over n, which is 8. So let's bash that into the calculator. Right, here we go. Sum of xy is 8880 minus sum of x, 130, times by the sum of y, 48, over n, which is 8. So you get 8100. 100. Okay, so now I can get b. B equals sxy over sxx. Again, when you write this down, make sure you put the values in. You show the examiner what the values are that you're using. So sxy is 8100. And we've got to divide that by sxx, which is 20487.5. Gives us 0.39536, etc., etc. I'm going to write down 0.395, 0.395. In fact, let's write down the whole thing. 395, 363, 363, 0262. 0262. Okay, I want to maintain accuracy when I'm working out A. A equals y bar minus B times x bar. Okay, y bar minus B times x bar. Let's try and do this in one go. Right, that's the value of B. I need to multiply it by x bar. X bar, in this case, is going to be 130. It's the sum of the values of x divided by the number of days, 8. So I'm going to multiply my answer by 130 over 8. Okay, so now I know what b times x is. I'm going to multiply it by minus 1 to make it negative. So now it's negative. And then I'm going to add on y bar. Add on y bar, which is going to be found by doing 48 divided by 8. 48 divided by 8, which is 6. So we get a value of A is minus 0.4264 minus 424649. 424649 minus 0.424649. Let's write down the full thing. 424649 1763. 1763. All right. We're not quite finished yet. I'm going to continue it down here. So let's write it to 3 significant figures now. So y equals A, which is minus 0.425 plus B to 3 sig figures is going to be 0.395 times x. Next part now is to hence find the equation of the regression line of f on m, and we're given the coding here. So f on m, so wherever I have an x, I'm going to replace it with m minus 250. So, and wherever I have a y, I'm going to replace with f minus 100. So instead of y, I'm going to put f minus 100 equals minus 0.425 plus 0.395 times by x, and x is the same as m minus 250. M minus 250. Okay, so f minus 100 equals minus 0.425 plus 0.395 times m, and I'm going to do 0.395 times by 250. 0.395 times by 250. Computer's gone a wee bit slow here. Just wait on things to catch up. Okay, just 1 second. Okay, a few technical issues there. Let's just work this out now. So 0.395 multiplied by 250 gives me 98.75. So minus 98.75. So F equals, so it's 98.75. I'm going to subtract, beg your pardon, let's change that. So minus 98.75, which is this part. I'm going to subtract 0.425. 425 gives me that, and then I'm going to add 100 onto it because we're adding 100 to both sides. Adding 100 on, we get 0.825. So 0.825 plus 0.395 times m. And then the last part of this question is predict the amount of fuel used on a journey of 235 miles. So F equals 0.825 plus 0.395 multiplied by the number of miles, 235. Out with the calculator. So 0.825 plus 0.395 times by 235 gives me 93.65. So 93.65 litres. Okay, a young family were looking for a new 3-bedroom semi-detached house. Local survey recorded the price X um, in in thousands of pounds and the distance Y in miles from the station of such houses. The following summary statistics were provided. Calculate the PMCC. Right, PMCC R equals SXY all over SXX times SYY. So SXY is minus 808917 divided by the square root of SXX 113573 times by SYY 8657, and we get minus 25.9798. Minus 25.9798. Something seems grossly wrong here because I have a value that is much bigger than 1. The PMCC should only be between minus 1 Let's double check there what we've done. 0.80917113573 and 8657. Okay. Okay, I've had a look at the mark scheme and it seems that there should be a decimal place right in there. So I'm going to add a decimal place in. Let's go back. 8 point. Okay, and we're still getting a particularly large value. Let me check the mark scheme again. And the mark scheme has revealed that there is also a decimal place right in there, a decimal point right in there. Okay, so apologies for that. It obviously didn't transfer over when I cut it in. So here we go. Minus 0.815798129. Let's go to 3 sig fig. Minus 0.816. Give an interpretation of your answer to part A. So it's a fairly strong negative correlation. Right, so the price goes, if the price goes up, the distance comes down. So in other words, the closer you are to the station, the more expensive the house. Let me just double check. A local survey recorded the price X in thousands of pounds and the distance Y in miles from the station. So as the price goes up, the distance comes down. So if you're closer to the station, your house is more expensive. So let's say the closer the house is to the station, the closer the house to the station, the more expensive it is. More expensive. So in other words, if you're close to the station, it's going to be an expensive house. If you're further away, it gets cheaper. So as the distances increases, the price of the houses comes down. Another family asked for the distances to be measured in kilometers rather than miles. State the value of the PMCC in this case. Well, in other words, it would be coded, and the PMCC is still going to be minus 0.816 because the PMCC is not affected by coding. Okay, the scatter diagrams below are drawn by a student, and the student calculates the value of the PMCC for each of the sets of data. The values were 0.68, minus 0.79 and 0.08. Write down with a reason which value corresponds to which scatter diagram. Okay, so let's have a look. 0.68. It's a fairly weak positive correlation. And it is, sorry, yes, well, relatively strong in comparison to the rest is positive correlation. So that would correspond to diagram C. The reason, as it is relatively strong, positive correlation. Compared to 0.08, and the diagram suggests this also. suggests this also. Okay, let's see, minus 0.79 is the only one that's negative correlation, so it must be diagram A. Diagram A, as it's a strong negative correlation. Negative correlation. In other words, as x increases, y decreases. And finally, that must mean 0.08 must correspond to diagram B. As both value of PMCC and diagram suggest little. Oh, we don't want that to happen. Let's come back. Suggest little correlation. A fairly straightforward question there to answer. All right, let's keep going. As part of a statistics project, Jill collected data relating to the length of time to the nearest minute spent by shoppers in a supermarket and the amount of money spent. Her data for a random sample of 10 shoppers are summarized in the table below, where T represents time and M is the amount spent over £20. Write down the actual amount spent by the shopper who was in the supermarket for 15 minutes. Okay, so this supermarket was T represents the time, so that's 15 minutes. And it says minus 3. So I need to add 20, which means they spent £17 because M is the amount over 20 minutes. So if I add 20 to this, I get 17. They've spent £17, which is £3 under 20. Calculate STT, SMM, STM, and we're given some summary statistics. Right, STT will equal the sum of, it's going to equal, we're going to need to work out the sum of T. Alright, first thing I'm going to do is I'm going to use this data and I'm going to plug it into the calculator. So let's go mode, stats, two variables, and I'm just going to enter all this data in. T is going to be my X, M is going to be my Y. So I'm going to pause the video and just enter this data in now. And just entering the last one in there. So that's my data gone in. In order to get STT, I'm going to need, it'll be the sum of T squared, which is 5478, minus the sum of T all squared. So I can take that out of here. Sum of T is the same as sum of X all squared, and that is to be divided. Has to be divided by n. Again, you can write all of this down. Sum of T squared divided by n, which in this case is 10. Right, so we get 983.6. 983.6. I need SMM. SMM is going to be the sum of M squared, 2101, minus the sum of M all squared, which I get from here, the sum of M, which is the same as the sum of Y in this case, sum of M all squared, divided by 10. and we get 1728.9. And finally, STM will equal sum of TM 2485 minus, let's bring up some brackets. I need the sum of M, or sum of T, which is the same as the sum of X, times by the sum of M, which is the same as sum of Y in this case, divided by 10. And that gives me 1191.8. 1191.8. And then we're asked to calculate the PMCC. We could use the traditional method. I'm just going to use the calculator to do it. So go into regression, choose option 3, which is the value of R, and that gives me 0.914. 0.914. So 0.914. Let's just cross-check it. Let's check and see if it is correct. So what would we normally do? We would do the sum of xy, or in this case sum of STM, 1191.8 divided by the square root of 983.6 multiplied by 1728.9. 1728.9. Let's check and see, do I need to close? I do need another bracket. Another bracket, let's hope. 0.9139, same answer, exactly what we were looking for. Excellent. Alright, write down the value of the PMCC between T and the actual amount spent. Give a reason to justify your value. Now the actual amount spent was, I'd have to add 20 to all of these. So in other words, it was coded. So it's going to be the same because coding doesn't affect the PMCC. So it's still going to be 0.914 as coding does not affect PMCC. Alright, on another day, Jill collected similar data. For these data, the PMCC was 0.178. Give an interpretation to both of these coefficients. So in the first instance, we got a PMCC of 0.914, which suggests that longer time shopping increased the spend. Whereas in this case, we have a very low PMCC, which suggests that there's very little relationship. So for 0.914 suggests longer shopping time increased the spend. Whereas for 0.178 suggests GEST, apologies for the terrible handwriting, suggests no link between, or a weak link should I say, very weak link between time shopping and amount spent. Okay. Suggest a practical reason why these two values are so different. Right, there's lots of things we could say here, such as um, it could be the time of the month when people get paid, so they're likely to spend more money. It could be the fact that it's a weekday or a weekend. There's many different things you can say. There could be a sale on, so people are likely to spend more money, and they might spend more time and spend more money. There's various different things you could put down here. So we'll just move on from this one. Um, okay, a metallurgist measured in length L millimeters of a copper rod at various temperatures and recorded the following results. The results are coded, and then we're asked to calculate SXY and SXX. Okay, so the first thing we're going to have to do is build a little table and then provide some coding. So I'm going to pause the video and build the table. Okay, so I got my table built here, and I need to code it. So x equals t. These are all going to be the same values: 20.4, 27.3, etc. L equals, or y equals L minus 2460. Taking 2460 off, I get 1.12. I'm going to get 1.41, and again, I'll just pause the video here and fill out this table. Okay, table is completed. Now I'm asked to calculate SXY and SXX. Well, SXY equals sum of XY minus sum of X times sum of Y over N, which in this case is 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got the sum of XY, which is this value here. I don't have the sum of X and I don't have the sum of Y. So because this question is a little bit continued, I'm going to plug these values into my calculator so that I can save myself a bit of time. Okay, great. So I've got the values plugged into my calculator there. So let's just use the calculator to do all the hard work. So shift stat. So I need the sum of XY minus, and I need to do the sum of X times by the sum of Y divided by N, which is 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. And we get 71.4685. 71.4685. I also need SXX, which is sum of X squared minus sum of X all squared over N. Again, let's get the calculator to do the hard work here. We should be fairly familiar with this at this stage. So sum of X squared minus sum of X to be squared divided by N, which in this case is 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, just double checking there. And we get 1760. Let's go with that. 1760. 1760. We might as well do the rest. 45875. 0.45875. All right. Find the equation of the regression line of y on x in the form y equals a plus bx. Okay. Again, let's use the calculator to do the hard work here. One stat regression. The value of a is this 0.3243641111. So 0.324. Let's go with that. Equals 0.324. So that's A. A equals 0.324. B equals, again, let's use the calculator to get all the hard work done. Regression, value of B, 2. 0.04 0.0406. 0.0406. So y equals 0.324 plus 0.0406 times x. Estimate the length of the rod at 40 degrees Celsius. Okay, let's just double check which the length of the rod at 40 degrees. X is t, so I'm going to put in a value for x. I'm going to let x equal 40, and that gives me y equals 0.324 plus 0.406 times by 40. Right. 0.324 plus 0.406 times 40. We get 16.564. 16.564. Now, is that going to give me a correct answer? That gives me a value for y. However, y was coded by doing this. Okay, y was coded by doing that transformation. So y equals L minus 2460. 2460. So I know that y is this. So in order to get L will equal 16.564 plus 2460 gives me an answer of 2476.564. Okay, find the equation of the regression line of L on t. Well, x is t, x equals t, and that's what y equals. So we're going to transform this equation. X is t, so we get t equals 0.324. Beg your pardon, that's wrong. Y is L minus 2460. So instead of y, I'm going to put L minus 2460 equals 0.324 plus 0.0406 t. That implies that L equals, adding 2460 to both sides, we get 2460.324 plus 0.0406 t. Estimate the length of the rod at 90 degrees C. So I'm going to plug 90 in for t. So we get L equals, let's plug 90 in for t. And we get 2460.324 plus 0.0406 times times the temperature, which in this case is 90. 2463.978. 2463.978. 63.978. And comment on the reliability of your estimate in part E. We chose a value of 90 degrees. 90 degrees is way outside the range of data shown, so it's unreliable as outside the range of data. The range of data. Okay, and that's it for the video. An incredibly long one. That was a bit of a slog, but hopefully by the end of this, you should be an expert in solving exam questions on correlation and regression. I'll be back soon with a video on probability, and we've got some discrete random variables and normal distribution to do also. But that's it for now, so best of luck with the revision, and we'll talk again sometime. Take it easy.